So we will start Databricks Delta today. And then we have Spark internals, how Spark works internally, and Unity catalog. So these are the three concepts. Of course, there are a few more we will touch upon, like joint strategies and other stuff. That's on the Databricks side. And other than that, we will cover Amazon Redshift uh, on that, and Airflow. So Pawan is working on giving you guys some assignments, basically projects, which has all of these, which you need to come up with all of these, connecting all of these components, basically building the data pipeline with having some of these as sources and some of these as target, and Databricks as the processing engine in between. So processing through source, streaming, batch, event driven onto this Databricks, and then to publish to target, source, and sync. One more thing is that it's not much. So focus on the batch and getting data, or maybe events, but don't get too much onto the streaming. You get very less. So basically 60 to 70% of the use cases are all batch, only 20 to 30 or event driven, if you have huge uh, volume loads, and most of them use Kafka or to connect with the data streams. So if you are at least confident about the uh, architecture of all of these tools, um, then you will be comfortable. Okay, and then you practice how this is going, and also hands-on. This is, we said, like one track. The other track is about building your resume and getting ready for the interviews, and the um, third track is your certifications. Okay, start thinking about it. So there's one Databricks certification you should do for the interviews, and there's another one in Snowflake. It is if you are interested. So one of these two, basically in the market, the data engineering, you have these two skills are in demand, popular. Of course, you need to have the knowledge, working knowledge, expertise, experience of other tools like Airflow and Kafka and Event Hubs and other stuff. But these are the main two processing, data engineering platforms that you should be aware of. Okay, so that's the thing. Maybe we'll have around 4 or 5 more sessions. Some maybe during the weekdays and some on the weekends, but most likely in next week or two, we will wrap up these things, and then we will move on to the preparation for interviews and preparation, certifications and all of that. Okay.
Yes, sir.
Yes, sounds good.
All right. So let me give 1 second to log in, and then I will share my screen. Hi, Ramya.
Hi, Karan.
Sorry, I think are you able to hear me okay, or is the volume low?
No, it's good.
All right. Okay. So today we'll be talking about the Databricks Delta, right? So we are creating tables, right? So we have been creating tables and creating database, creating tables, writing data into these into these tables, right? Bronze, silver, gold, batch data. So when you are writing it, the data is getting stored, right? So where do you think the data is getting stored? Where is the data getting stored?
It's getting stored in a data frame.
The data frame is in memory.
Yeah, in memory, yeah. And then tables. Then
Whenever you say data frame
Mhm.
is only available when you are running, when your job is running. Okay, it's only in memory. Once the job is done, they are all gone. Data frame is not on the storage or on the database. So that's only in memory. Now, the temporary views you create are also in memory. Okay, once your job is done, those views are all cleared. Okay, persisting to database, when you write data frame dot write to a table or to a, so where is that getting stored?
On the database somewhere.
Okay, yeah, it's going to the database. So what happens in the database? Where is the database? Where is it stored?
On the cloud.
Okay, so basically when you are stored, yeah, Ramya, sorry, you're typing something.
AWS S3.
Yeah, AWS S3, maybe. Okay, so yeah, you're close. Basically, you see, whenever you are creating a table, okay, let me first start my compute. Okay. So whenever you create a table, your table is getting created in some location, correct? So that is on the, there is some path you give to create that table. Maybe you give your database, you give schema, you give your table, but ultimately when you write that table to database, so that is getting stored on some storage, because end of the day, all that happens behind the scenes, under the hood, okay, in the database, is there will be a file somewhere. It is written in the machine readable format, optimized, zipped, encrypted. So there will be somewhere it is written. So whenever you access the database, you are not directly reading the file, but when you access the database, the platform or the database will do all of those operations. So it knows where that is located. It goes there, looks at all the files, decrypts it, uh, and then unzip and decrypt and read the data. Make sure based on your query what data it has to filter, from which file it has to get that data and where it is located. All of that it does before it is just, when you say select this from this table, all of that is happening before it gives you back the data. So which means end of the day, they are stored in a file somewhere. Okay. And that you say, when you say Databricks, there is a Databricks, when you create a table and you save it as Delta, there is something called Databricks Delta layer. So that Delta will create all of these files and store. It can be DBFS or it can be, as Ramya mentioned, on the cloud storage somewhere. So underlying it will be cloud storage everywhere. So Databricks and Snowflake both sit on one of the clouds, AWS or Google or Azure. That you have to be very um, comfortable with, confident with. There are three cloud platforms: Azure, I mean, not three, so major. Okay. So major three cloud platforms, popular ones: Azure, AWS, and Google. And these are the cloud platforms. They provide storage, they provide computing power, right? And they also provide a lot of other services called, uh, processing, storage, and compute. And also, uh, when you want to have your own database, you can also put your database on the cloud. Say, for example, you have a SQL Server, you have Postgres, you have MySQL, any of your databases, you can host. So they also provide hosting services. You can host your databases on any of these clouds as well. So these are the clouds. Apart from hosting your databases on the clouds, the cloud will also provide their own databases, like Amazon provides Redshift, Azure provides Cosmos, MySQL is from Azure only, and the several others. Google provides BigQuery, and other NoSQL databases as well. They offer some their own databases on the cloud for you to use, right? And then some their own machine learning models or hosted models. So all of this. So it's like a shop. Okay. Basically, if you look at if you go to a mobile shop, right? So think of it as a mobile shop, T-Mobile, right? If you go to Apple store, what products do you get? If you go to Apple store, what products do you get? Guys, come on, talk. You're all on mute. Are you still there, or am I talking to myself?
Yes, sir.
Yes, sir.
Yeah. Okay. So when you go to Apple store, what products do you get?
MacBook.
Sorry?
MacBook.
Apple products. Okay. No, I'm not able to hear you, but that's fine. So when you go to Apple store, you get Apple products, right? iPhone or iPad or whatever. But when you go to a telecom shop like AT&T or T-Mobile, there you also get Apple products. You can buy Apple iPhone from them also, and you can also get the Samsung, right? So they sell both. But if you go to Apple, you go only get Apple, right? So something similar like that. The cloud platforms are like telecom shops. They sell all. I mean, they have all. Like they have their own services, but they also can host your services there. Okay. So you can host your, for example, Postgres database on the cloud, or you can take their own Amazon Redshift database you can use, right? Similarly, Databricks and the Snowflake, they are hosted on these. So internally, when you create a compute, they get the machines from one of these cloud platforms, right? So they rent it for you, and then you can use, and they take care of paying you pay the Databricks or Snowflake, and they internally they pay up whatever for these cloud services for the usage. Same for the storage. Storage means if you're creating all the tables in Delta, so you don't need to worry about where it is going. So Databricks will take care of where it stores, and when you need, gets it and gives it to you. But if you're directly using S3, that is between you and Amazon AWS. If you're using Delta, internally where it stores is not your problem. So um, these are three cloud platforms and popular data platforms, data analytics platforms, which we use for data processing, data analytics, and machine learning and AI. Two popular or as a databases, data warehouses is Snowflake and Databricks. So these are the two popular ones. The underlying Google, AWS, and Azure also have similar capabilities, but they are not in the same league, or it's not the same comparison between these two. They are in different categories, basically. Right. So why I'm telling you all of this is you have to be very clear of the concepts that you don't mix up. Okay, when somebody is talking to you, maybe in interview also, you have to be very clear what are all of these platforms, what are the data analytics platform, what is the cloud platform, what do they offer. Okay, don't get confused and misplace the services. Okay, so when they ask you, you have to be very clear which platform provides what. Now, as I said, when you create compute, so you pay up, Databricks charges you, and then it goes to Azure or AWS or whatever. When you create Azure Databricks, that's how you pay up. Internally, they take care of all the machines and all of that. So storage also, it says Databricks file system, right? We have talked about DBFS. So we are looking at files, right? So whenever you upload files from here, it goes to DBFS. So similarly, it will store somewhere, and then you can, it gets you the data when you read. But what happens when you do transactions on those tables? Okay, and how Databricks stores, how Delta stores, and how it enables the features of, like, say, CRUD operations, create, update, delete. What happens when you do these transactions? It is easy. It is, you can say it's it's there everywhere for all databases, but for big data platforms like Hadoop and all, initially they were only read only. There was no ACID transactions like update or delete. It was only append only. But later Delta came in, Databricks came in with Delta, and then they started providing those features on the big data as well, update and delete. So now they are transactional. They support CRUD operations with ACID transactions. So that is what we're going to explore when you say with Delta, Databricks Delta. Delta is a format which is specific to Databricks. Remember this. Format is again two categories. Delta is at the top layer, Databricks format, Delta format. Underlying, when it stores, when Delta stores data in the file format, what is the format of the file?
Market.
Yeah, Parquet. Okay. So if you look at so when you look at this, right? So Delta Lake, it is Delta. Here in the bronze, it shows this triangle, right? So this is Delta, but underlying files when it stores are the in the Parquet format. Parquet is the file format. So like we said, Parquet, ORC, CSV, Arrow, Iceberg. So these are all different file formats, which are very optimized or columnar for querying. Okay, so we will look into what is happening when you create a table, when you go and do transactions on this in the Databricks Delta. Now I'll give you architecture diagram, then you can follow that and see where all of these fit in the architecture of the whole Databricks. Okay. Now, what is the Delta Lake? It's an open source storage layer for data lakes that bring ACID transactions to Apache Spark and big data workloads. So you're using Spark, right? So and then you're using the Delta format, save as Delta in the dot format you mentioned Delta, and then it will store. It ensures ACID transactions. You should talk about. So you should talk about all of these when you talk about Delta, the features. What is ACID transactions? Anybody know ACID transactions?
Yeah, for A, it
Atomicity,
represents, yeah,
consistency, isolation. And durability.
Yeah, right. Anshu, you're saying?
Yeah, I was saying the same thing.
Okay. Yeah. So accessibility, consistency, idempotent, and I think what is the D you said?
So atomicity, consistency,
Yeah.
isolation, and durability.
Durability.
Yeah, durable. So basically, these are the characteristics of a database, relational database, that it has to satisfy to be able to qualify as a database. Each of those will talk about the what it means properties, like every time you should get the same response when you do. It has to be a complete transaction. You should not put in half transaction, and otherwise it should roll back. uh, it should be the data should be available, basically persistent. It's not like it's there now, it's not after 5 minutes it's not there. So something like that. And um, it kinds of it talks about those four properties which we call ACID transactions. This is all for the relational database or the transactional database. So those qualities, those transactions, Databricks has brought to the Delta using the Delta layer on top of the data, so that it satisfies the ACID transactions. It unifies batch and streaming. A table in Delta Lake, it can be used both as a table for batch processing or as a stream processing, right? So we were seeing, you can say dot from the table, you can say dot read, or you can say dot read stream. So the same table can act as your standard table just to read from, or it can act as a streaming table for you. In the, if you want to connect it in the streaming layer, you can stream the data from the table also. The same table can act in both the ways. So a delta table can act in many ways. It's the beauty of it. It's not like you have to create a separate table for a streaming and separate table for batch. So the same table you can use for both. So a delta table can be a table for a batch. It can be for a streaming. It can be used as vector database. For vector search, can create the same delta table. You can create indexes and use it as a vector table to do vector search. So the same thing can be enabled on any of these on the delta tables. Okay, it's both a batch as well as streaming, source and sink. So you can use it as a source or you can use it as a sink to write into. Streaming data, ingest, batch, historic, backfill, and interactive queries all just work out of the box. Schema enforcement and evaluation ensures data cleanliness by blocking writes with unexpected changes in the schema. I think this is cut out. So how the schema enforcement happens and how you can enable the schema evaluation. Time travel, you can query previous versions of the table by time or version number. Delete and upserts, you can do deletes and you can do update or delete with programmatic APIs. If you have an API, you can use the API, you can call the APIs, trigger the APIs, and do those operations as well. Not just as a batch or streaming job, you can also use APIs, event driven, to do some transactions. So stored as Parquet format in blob storage. So this is what is stored finally in under the delta. So when you call it delta, it is stored in the Parquet format. Any system or any third party application can can access or read the data if they can read a Parquet file. Audit history, it has history of all the operations that happened on the table. Able to handle millions of files. Scalable metadata management, scaling the metadata operations with Spark. So there are other things like optimize, Z-order, optimize, and vacuum that we will go through. But these are the features. So we'll go through this. First, this is the use case. There is a file that we are like downloading. So we don't have this yet. We have not created now. That's fine. Let's connect the cluster. This is setup. Okay, don't worry about this. Just we are trying to get a file in this. We are downloading a file using wget from HTTPS pages Databricks. This Parquet file we are getting and downloading to our Databricks file system as this file name in this folder. Okay. Once that is done, we will just first check if the file is available. Okay, file is available. Now this is a Parquet file, okay, not a CSV or whatever. So what we are doing here is we are reading a Parquet file and then writing it as delta table. You get it, guys? So these are all, so we gave this path. This is the file path that we downloaded. And then we are saying read format Parquet file, load from this path. With column, we are adding a column called type, which is batch. And we are adding a timestamp or current timestamp. Are you guys with me?
Yes, sir.
Okay. But have we created this? Delta. Okay. Okay. So let's run this. Okay, so that is done. We'll go here. Catalog. Delta DB. Loans delta new. Okay. So this is the schema. Remember, we added type and timestamp. And then you can see timestamp is current timestamp that we are generated when we are writing this, reading this file and writing to the table. So it has a loan ID, funded amount, paid amount, address date. Okay. So this is the, this is all setup that we have done. Now we'll go into what happens in the delta when you write the table, right? So this is spark.sql or just SQL. You can write what did we do? We saved as loans delta new. Okay. So we have these transactions, these rows, tables here. And then, so we look into what is the asset transaction. So before going there, when I say describe history, so we can do describe history on this, what happened on this table. So this table created version 0 with this timestamp. So remember, keep in mind, remember this version. Okay, 0 is the version. First we created this table. So the username what is the operation that happened that created this table. This is history. On the table is we did a create or replace table on that is the version 0. You have operation parameters, you have notebook, you have all of these metadata. Okay. And you can also see here some metadata, operation metrics, number of files, output rows, and output bytes. 14,705 records we have. That is same as here. When you do select count star, you get the same records, 14,705 records. And that is what we are seeing here. 14,705. Okay. So remember, so this is all like metadata. When you are saying any database table, you describe, you get this thing. This is history of the table. So we talked about earlier, you can get history of the audit history of all operations that happened in the table. So that's what we are doing here. Okay. Now, you can do all of this SQL, right? There's nothing great. Min, max, all of this stuff. It's just showing what are all you can do on the table that we have already done. We have been using that all SQL on that. So now check this. So this is something interesting. Describe formatted loans delta new. So we are doing a describe here again. What is showing here? The column name and data types, the metadata of the structure of the table. That is fine, right? So column name we have, data type we have. If you go to detailed table information, it says what is the database, delta DB, catalog, table name, created by this Spark and all of this. Type is managed. Okay, there are two types of tables. One is managed and one is external. You can read up about. So managed means it is completely owned by Databricks Delta, where if you drop, this is a important concept. Even if in interviews, if they ask what is the difference between a managed table and the external table, managed table is you own the table structure and the data. So if you drop the table is dropped and underlying data is also dropped. Okay, it's like drop table in database where underlying data with files, everything is deleted. External means you own the table, metadata, but you don't own the data, the files inside it. You're just pointing to some location where the files are there. That is external data. You are creating a table on top of that for reading and writing. So if you do that external table, when you drop that external table, only your metadata is dropped. Your table is dropped, but the data or the files are still there. Somebody else may be creating another external table on the same data. So they will still continue to see the data because it is shared or external. So these are the two different types, managed and external. Managed is you own both the metadata and the data, table structure, table and the data. And if you drop, everything is gone. Table is gone, structure is gone, and the data, files, everything is gone. In external, you only own the metadata or table. You just share or point it to a location where the data is there, files. So when you drop that, you can only drop your table structure and metadata. The underlying files and data will still be there. It's not gone. Okay, so that is the difference. It's like drop table and then basically truncate kind of thing, but don't get into that. So this is the concept. Okay, managed, you drop everything. External, you only drop the structure, but the data is still there. Now location. So this is the new interesting thing that happening. So location, when you say yes, it is in Delta DB, it's called loans delta new. That is for us to access the table or access the data. Now underlying data is going here. So this is the path where it is storing the location of the actual data. DBFS user hive warehouse delta db.db / loans delta new. So this is the path where the data is going. We will take this and then see and go to that location and then read the files, right? So that is a path, and then we can see what is there in that path. So if I go there, user hive warehouse delta db loans delta new, so and I query this file system, so I can see two files here. One is delta log. This is a folder we can see, and then there is a file called loans part 0000 ending with snappy.parquet. Okay, snappy is your compression, your zip, zip the file. So Databricks uses snappy to compress the files, and this is the parquet format, right? Snappy.parquet. So this is a parquet file. Is it? So it has the data. Now, what is there in the delta log? So this is important for us. Okay, so we'll go to delta log, and then we will check what is there inside that folder. So if we go to delta log folder, right, and then see here, there are 5 rows. There is one CRC, there is one S3 optimization, S3 optimization 2. Okay, we are not concerned about this optimization things, but we have a file called JSON here. This is what we are interested in. So in each delta log, there is a file called, there is a JSON file. These are called the transaction log. This is the most important. It's like a heart of the delta. Transaction log. All the metadata about your transactions is recorded in this file. This file will tell you what data, or tell rather the delta, the Databricks, what files are active, what are inactive, which data is in which files, what are the columns, what is the data, what is the max min values of those files, right? So all of that metadata is in this. If you remove this, or if this is gone, deleted or corrupted, then you cannot do anything with your table. That is becomes useless. So this is kind of a heart of all your transactions of the table. Now, what does this JSON have? Okay, so we can go here and say delta log. So this is the file. Let me just make it 0. And I'm just trying to view it first as head. I'm just trying to read the file as is, raw file. So it looks something like this. Commit info, user ID, username, operation, create or replace table as select. Remember, we were seeing in the table history, right? So the same one here, create or replace. Where is audit history? We looked at, yeah, history here. If you go here to the history, it says create or replace operation, right? So where is this getting from? It is getting because it is storing it here in the log. So that is where it gets and displays. It also talks about, see here, output rows 14705. So when you say count star, this is what reads and it gives you. It will not go to the file and then read everything, count it and all of that. Some of it pre-calculates and stores in the metadata so that it can give you faster. Output bytes, and it has, look, and then it has all the metadata here about your columns as well. Okay, format is Parquet schema string. So it says type is struct. Fields, what are the fields? Name, loan ID. What is the data type? Long. Whether it is nullable or not, true, right? And then for named column, and then metadata again, funded amount, the type is integer, nullable is true, and then for paid amount, type is double. So basically it stores all the schema of the columns. Okay, so that information is also stored here. Next, if you go after this, what are the partition columns? So basically, you can partition the, I think it's a standard database feature. You can partition your data by some columns so that accessing the data is easier. For example, I'll tell you, if you have sales data, okay, sales data is coming from different states, all 50 states of the US, and then you're storing all the data. And most users are mostly accessing the data for each state. Okay, sales by Texas, sales by California, sales by Washington, and they're working on it. So it will be easier if we store data for each state in a different file or in set of files. Somehow we segregate and write that data. So if you write that, when you write a query, it can go to metadata and say, hey, for this state, what are the files? For California, what are the files? For Washington, what are the files? And it can directly go and read those files instead of reading all the files and getting data for California from file, read 10 files and then take 2 files, the data is there, right? So that is partitioning. You partition based on some of the columns you think or mostly how the users access it to read. Okay. Or if you take HR by department, the people maybe HR department may be accessing things based on the department. So you can partition that data by department. Okay, something like that. So that information it will store here, right? Partition values, modification time, and all of that. Then it will also store some statistics, as I said. What are the number of records? 14,705. What are the minimum values for each of the columns? For loan ID, minimum value is 0. Funded amount, it is 1,000. Paid amount, it is 0. Okay, so these are the minimum values. For strings, it's okay. It's mostly like, by order. Okay. But for the integer values, numbers, it matters. And then it will store maximum values. What is the loan ID? Maximum ID for loan ID, funded amount 40,000, the paid amount, what is the maximum, right? And this. Okay. Question. Why do you think it is storing minimum and maximum values? Where is it helpful? Yes.
To validate the
One
incoming
at a time.
data. To validate the data that is coming in, right? Funded amount.
The data. Okay.
Yeah.
Anybody else? Somebody else was talking. Somebody else was saying something? No? Okay. So min max values are used when you do a where clause. Okay. So when you say where loan amount is say 5,000. So it will go and search in that file. Does it fall in this min and max here? Or which files it falls under, right? Those kind of statistics it can get. Or when you say, give me max loan ID. So it doesn't have to do anything. It doesn't have to read any of the files. It can just go here and get the max or min for any of the things. If you directly want to read the max value or min value queries, it can directly get it from metadata instead of going and reading and calculating every time all your data. So all of this metadata is stored here. Max insertion time, min insertion time, optimize target size, all of this. So this is your metadata. Okay. Now we can also read it because it is JSON file. Spark can read JSON files, right? So I can go here and say read JSON delta log. It's a 0.json. And then I can say display and run this. Path does not exist. Okay, this is different path. Let me take this. Okay, if you see here, commit info, so metadata, it is passed in this object. You can see, same information. We are just putting it structured in the schema string, object configuration, created time, partition column, schema string, all of this in metadata. And you have the data change. So this is only, important for your interviews, basic concepts, how delta works. You have to talk about the delta log, the transaction log, which is stored in the delta log as JSON files. That's how Databricks manages the transactions, asset transactions, and CRUD operations on these files, on the data. If you see here, object, you see size, stats, min max values, insertion time, and all of that. So we know this. We are reading batch streaming. It goes to raw data, bronze, and then filtered, cleaned in silver, then gold. This is the medallion architecture we are talking about. And from gold, it can go to ML or BI, business intelligence dashboards, or machine learning. Now, schema enforcement is to protect the data quality. How the schema? So we have seen what are all the columns and what are the data types there. We create a new table that has an extra column called credit score, which is not there in this table. We'll create a new data frame with that column, which does not match with our delta lake. Suppose there is a new file that is coming in. They're reading the data and then they want to push the data into this table that we have just created, loans delta. But that file has an extra column called credit score. Okay, so to mimic that, we are creating a data frame in here internally, just in this code block in the cell with this data. Okay, this is the format just like CSV file, but in the end, with the date time stamp, there is one more called credit score that we are adding, one more column. So how we are creating? We are created this column here using this syntax. We are creating a schema. We are taking existing tables schema dot fields. We take all the existing tables fields plus, and then we add this field to it. So then we get the new schema. So old schema, 6 columns or 5 columns, whatever, plus this new column called credit score, 7 columns you get. So that is your schema, and this is the data. So you can create a data frame using spark.create data frame, and you pass this array, right? This array of values as data and the schema. So it will take the data and schema. It will create the data frame with the new schema and data. So you can see here the new schema that is coming in has credit score, and it also has some values. But our old data does not have this, correct? Our old table, where is that? Yeah. So our old table has only loan ID, funded, paid, address, type, timestamp. It does not have credit score. But the new data frame that is coming in, which wants to write data into this table, it has one extra column. So what happens if it just try to write that? Okay. So I'm just doing new data dot write. New data dot write format is delta. Mode append. I'm adding that data to this table. Loans delta new that I created. So if I run this, so we get the analysis exception, which says schema mismatch detected when writing to the delta table. To enable schema migration using data frame writer, so just click this. Please set option. There is another option it's saying. It is also saying how you can resolve this issue by saying merge schema true. In Spark also, you can set this flag or option, but here also you can do when you're writing option merge schema true. So what it does is, see, it is showing this is the table schema you have, and this is the data schema you have. So you have this schema, you have this schema, they are not matching because there is a credit score extra here, which is not here. So that is why it is not able to append to the data. Then what we do is, we again try another time to write same delta append, but this time we add another option called merge schema. So you're merging both the schemas. So new schema and old schema, and then writing. What happens when you do merge schema is the new format will be overwritten on the old format. So then you will have additional column on top of the old schema. Okay, so if you see here, now if I run this time it will go through. Okay, there is no error because we added this merge schema. So it will also now add that credit score. But where does it add? It will add to your table, add a new column called credit score. Okay, so now we have done some transactions on the table, correct? Now we have to go back and see, hey, what's happening on the table history, right? So if I go refresh and go to history, see now there is a new version that is created called version 1. So this is 0. Initially when we created create or replace table, there is a version 1 that has come in. At this time, operation was right because we added some data, right? We wrote some data into the table. So the operation is right. There is no mode is append here. You can see append and all of this metadata. So number of files is 1. Output rows is 2. So why it is 2? Because we added 2 rows. We added just 2 rows, right? See here, yeah. So our data frame had only 2 rows that we wrote into the table. Okay, so that's why the output rows is 2. So it says we have written 2 rows. It has wrote 1 file, and that is the right operation that happened. All of that information, it is logged as history table. Logged as the table history, correct? Are you guys with me? Can you see the beauty
yes,
of
sir.
how everything is
Yes,
tracked
sir.
and logged?
Mhm.
Called data governance. Okay, so please remember all of these terms. All tracking, logging, monitoring, not monitoring, tracking, logging will come under data governance. Okay, so at any point of time, you should be able to go and look at and understand what happened on the table, who did, what operation it was done, what changed in the table at that time, who did that, who accessed, everything should be available for you. Things go wrong, you have to check, and then you get to fix. So just now, in the last yesterday we were having meeting with one of the clients, and then we were talking to them. We are trying to, as I said, we're doing an assessment to modernize their data platform. To move it to either Snowflake or Databricks. We have to do a recommendation reading their external, and we are talking to them. They're talking about issue where somebody has deleted some thousands of records from production. Okay, and it is not a database. It's some kind of file-based storage, and then they have some internal screens where they can read the data from the file and then do operations on the file independently. There is no database, nothing involved there. But they were not able to track. And the thing is that they were able to delete in production is the issue, right? So you should have strong data governance, who's accessing, who should access, whether they should have delete permissions on that table on the production. Nobody gives you delete in the production except there is a change management process that happens. The maximum you can get is only for the Nabi knows for the highest level of production support, level 1 or level 2 teams who can read data in production. But write, even they don't write, like adding, updating, or deleting, they don't have access. They have to fill up some applications change management process. It goes through multiple reviews. Director level, VP level have to sign off on that. Yes, it's okay, go ahead. After all of that, then they have to do that in non-prod environment and see if those script is not accidentally deleting more data or kind of a thing, or a different data than expected. So much of process goes in when you touch production. Okay, so these are all built-in data governance. So if something happens, so you should be able to track down the history of what happened. So this is where it helps, right? So data governance, and every transaction is logged, whatever happens on the table. Apart from this, there are other monitoring tools within Databricks also, Lakehouse monitoring, where you have inference tables and other thing, and then you have data lineage. All of that is available. That's a different topic. Okay, but for now, in the interest of time, let's move forward. So that is the history is maintained. Now you have two versions of the table, 0 and 1. Interesting. Now it gets interesting when we move to the time travel, right? So we did this. Yes, we did this. This. Okay. So now it gets interesting with time travel. So time travel is basically, you see here, snapshot at a given point of time. Okay, so every version is a snapshot. It's not that just it's writing what happened at that time, but it also saves a snapshot at that period of time, so that you have a clear demarcation of before that and after that. So you can go back and see, for example, the example I was talking about yesterday, they deleted, but they cannot get it back because it's a file system. It's just the data is stored in the file, and they're accessing the file directly and then writing the data into that file directly, deleting the data directly. But if they had this kind of, and so they were not able to restore that data, they had to reprocess from source, get some old files, and then reconcile and do all of that stuff. Suppose if they had something like this, time travel, right? Version 1, somebody deleted 100,000. That's fine. Let's go back to version 0, which was, when it was created. Version 1 was created. If you just go back and restore, everything is fine. You don't need to worry about anything what happened at version 1. Just gone. But that was not there. So here, you can query snapshots. You can go in time and say, hey, at that point of time, how does my data or my table look like? How did my table look like? What was my data at that point of time, right? So you can go and query in a point of time or in a version using time travel. You can go back and do the time travel. So how you do that? So same thing here, what we are seeing the history. Not only can you view a table in history, you can also do a rollback to that version, or you can get the data from that version and insert to the current version. So you can do a lot of things. It's not just only view. You can use that data as is to override the current version, like rollback, or use some data from there and then insert back into the new one. So whatever you want to, you can do that. So same thing, two versions, 0, 1. And then we are using time travel to select and view the original version of our table, version 0. Okay. So if you see, select star from loans delta new version as of 0. Okay. And I'm doing count version as of 0. So this is the syntax. You can put version as of and the version number. So if you see version 0, in version 0, you don't have credit score, right? Same table, if you put version 0, you don't have credit score. Guys,
Yes, Karan.
you see that, right? Okay,
Yeah.
and count 14705. This is the version 0. Now, if you go, don't put a version, it always takes the latest version, right? So latest version is 1. So it will go to latest version. And then here you can see credit score. Okay, for the old data, we didn't provide anything, so it will be null. And only for 2 records, it will be there because we added those 2 records with the credit score. Since the old data does not know credit score, it will just be null. This is the new version. So, and data is 14,000, count is 14,707 because we added 2 rows for the when it created the new version with new schema. Right? So, update. So, that is the time travel. Correct? Any questions here? Any
No, not from.
time travel? Ramya?
No question, sir.
No, no, Harun.
Narasimha?
No, no questions.
Okay. All right. Okay, let's get back. Okay. So loans, delta. So you got this version history. Okay. Now we will do some update for all loan ID less than 10. We can set a credit score to 500. So because currently they don't have any. If you look at what's the loan ID? Yeah, for all these, there is no credit score, right? So we can do an update on this loan ID. Okay, so we can do update. So 10 rows are affected. Now what happens to the table version?
Will get increased to.
Yeah, so there is a new table version that is created because we have done some operation on the table. Now you can go and check here. You can just refresh and see history. So there will be a version 2 and it will say operation is update. Okay. So and all the metadata will again be created there. Now, if you go and query as of version 1, which is now old. So for loan ID 0 to 9, it will still be null credit score. But if you do the same, if you do the same with without version, latest. So we updated, right? So anything updated is all, anything you write a query is all, it will take the latest snapshot. So latest snapshot, you can see credit score is 500 for all of this, 0 to 9. Okay. That is how the versioning or time travel works. Now you can, just 1 second, I need to get my charger. I think my laptop is dying. Okay, sorry about that. Yeah. So let's continue. So what we can do, so we said in version 1, in version 2, we have this credit score, right? This is the latest version. But when we do version 1, so if we display version 1, the previous version, the score is null. Okay. So now we can take the specific version and then roll back to that version. That's what I was talking about, right? So when you do restore loans delta, it's not delta, right? What is the table name? New. Restore loans delta new version as of 1. Okay. So I'll just run this. So the same time travel concept is also available in the Snowflake as well. Okay. But how you do it different, but the concept still is available. A lot of the concepts are features, basically concepts of features are available in both Snowflake and Databricks with respect to the data warehousing and the databases. So here you can see table after restore, number of files after restore 2, it removed 1 file, it restored 1 file. Okay. So basically it does not update the same JSON file. It creates a new file and then it makes even all the data it copies from old file to new file and make that entry in the transaction log. Okay. So if you can go back and you want to see after all of this. Okay. Let's see. Now, after the restore, we did restore here. So after the restore, if I after the restore, if I just go and check what is the data for this table, you see it gone back to null, even in the latest version, because we took the old version and rewrite it on the top of the new version. 0, 1, 2. So if I refresh, go to history. So I got a new version called 3. Operation is restore. Okay. So basically this 3 is same as 1 because we took version 1 and then restored it here on top of 3. So the restore version 3. It's all like, moving back and forth. It gets complicated, confusing when you go. So version 2 is also available. Now, if you want, you can go to 2 and then again replace it over 3. It becomes version 4. So you can keep doing, back and forth using all of this. Okay. Now, when you do all of this, we don't need this. We don't have version 15 and all of that. That was. So let me just delete this. But that is the then DML support, data manipulation language, delete, update, and merge into. So deletes are used to handle GDPR or CCPA request on your data lake. GDPR is like, I think, general data protection something. And this is California Consumer Protection Act, CCPA. So most of the organizations have to comply with these. It's basically simple customer protection laws. Like say, if your organization has my data, for whatever reason, I signed up, I registered, or I said, yeah, you can send me marketing emails because you gave me. So whenever they get some offer and all of that, but then I decided I don't want to receive anything, so I can request them to delete my data from their database. So they have to comply with that. So if they want to comply with that, they have to actually delete. And then they have some time frame within that. If they don't do that, the customer can sue you. Okay. And so these are all I think this is European one, and this is the California one. There are some few other things, but Databricks or most modern data platforms gives you the tools to comply. So these come under compliance. Okay, this is the compliance part under data governance. So these are the terms that you have to use wherever you find a entry and then use these terms. Like Databricks can also provide tools through Delta to make compliant GDPR and CCPA compliance that we have handled in our organization. We created scripts to comply with these processes. What it does is we are responding to a GDPR data deletion request. The user with loan ID 4420 wants us to delete their data. Okay? So we can just go select star from loans delta new. There's nothing great here. We are just trying to delete one record. So which is 4420 is there. We can go delete from loans delta where loan ID equal to 4420. That's it. So just delete. Done. Everywhere it's new. I don't know why we created new, but that's fine. So this is how you do the delete. Again, when you do the delete, same thing, it creates a new version, which operation delete. Okay, version 4, operation delete. This is most important. You can see what was used to delete predicate. We said loan ID equal to this. This is what we use to execute the delete operation. It will tell you which notebook has done that. It will tell you all the users, so how many files, copied rows, deletion vector, everything it will write from 14705 to 14704 it copied. Okay, one row it did not copy. Number of deleted rows is 1. Okay, you can see here. So all that metadata you can see here what happened in that delete. And specifically the username and timestamp when it was done and all of that. Okay, so that is like, you complied with delete, but then it's not completely deleted because see, the version is there, right? The older version is still there. If I want to, I can still go back to older version and get the same data back. That is not completely deleted. So you're still not complied with GDPR request. If you go to, say, any of the older versions, oh, no, sorry. I don't want to go here. Let's say 4420 is deleted, right? So now let's check what happened, okay? We know what is happening here. I'll just add one more. Take here SQL. Select star from loans delta new where loan ID equal to 4440. Correct. Version as of 2. Correct. No, say 3. 2 or 3 or 1 whatever. 3. So the first one did not return anything. Maybe we have to check. Sorry, let's check separate. Okay, no rows returned in the current version because we have already deleted. But if we want to go back, that is what we are doing, right? If something is deleted, we can always go back to the older version and still see. See here in version 3, that data is still there. which means we still have his data, not in the current version, but we still have his data. But that is not compliance. Compliance means it's deleted. It's deleted. Nobody should be able to see the data in the organization. So again, how it does is they have a retention period. Once you delete, it is invalid, but the files are still there. You can use it. But if you don't want all the invalid, then you can do a vacuum command. So that's when those files are completely deleted and then you cannot get them back, that data. So if you see, you can get the data again. And you don't want to roll back the entire version of the table, but you can still try to get the data from version 0 or version 2, version 3, whatever, and then insert into your latest version. So that also you can do. Data. Oh, because we have rolled back, right? Loans delta new. So why it is saying, see here, if you look at the version 0 does not have that column, but version has. So we can take from the previous version. The credit score column we added later. So from version 0, it is not compatible because the schema is different. So what we will do, version 3. So version 3 still has that data. So we can take from version 3 and insert into the current version. So guys, let me know if you're getting overwhelmed or getting confused. It's simple concept, just moving back and forth in the versions. That's it. So we took from there and then put it in the new version. The moment you add something to the current version, again, there is a new version created. That's as simple as that. So now it says you have inserted one more record in and it created version 5. It's a write operation. That's it. Create table, insert data, update, restore, delete, write. So it keeps on doing all of that history. So this is all done. So you can modify the existing. You can do an update. So we did that earlier, right? So we have seen that thing. So that will also create another new version. Now, how do you do an insert or update? So normally if you have to do, you have to identify new rows that will be updated. What are the things that are updated, not impacted, create new temp on 3 insert statements, delete original table, rename table back, drop temp table. All of that should happen in the big data world where these were not earlier supported. But Databricks with Delta got, identify rows and then use merge statement to do that with the ACID transactions. So how do you use a merge statement? If you're getting 2 new data, record to update and record to insert. So this is existing record 4420. You are updating with this data. There is a new record that you are going to insert, okay, with this. And then loans new schema. With this schema, let's say I want to add credit score of 100 and score of 600, and this is the new schema. So let me create that. So these are the two new data frame that's having these two records. Now we have to update our current table. Since this ID is already there, we cannot insert this. So we have to update this. This ID is not there. We have to insert. So how do we know what is there, what is not there, what we need to update, what we need to insert, right? So we created a temporary view called merge table with the data that is coming in. Now we can use existing table loans delta, and we can use this merge table, these two tables, that new data, existing data, and write a statement using merge. So that will figure out what needs to be updated and what needs to be inserted. So we are saying merge into, instead of saying insert into or update table, we say merge into loans delta as L using the new data, which is merge table that we have. Loans delta, so sorry, this is new, right? That's delta new, and merge table that we have as M. We are matching on loan ID. Both of them have loan ID to check, right, whether that exists or does not exist. When matched, which means when this ID is found in the existing table, like this 4420, which is already there. When it is matched, then we are saying update it. Update, set what columns you want to update. Star means it will update all the columns which are not key, which is not loan ID. When not matched, which means it is not found, then you're saying insert star. So then it will create, this will insert this row because it is not matched on the ID. It is not found in the base table. So you can run this. And once you run this, you can run this table. So here 4420, you can see it is updated type. I have updated the type to UPDXXX. So this is updated, and this ID is new, that is created with this type, with this credit scores. So that is the merge statement, which is basically your upsert statement. If row exists, first it will match based on the keys. If row exists, it will update. If it does not exist, then it will insert. Now the last thing that I wanted to, every time I run out of time here, is vacuum. So vacuum deletes all files no longer needed by the current version of the table. So if you do a vacuum, all your files that are not needed by the current version, they are deleted. So then you cannot get them back. So you'd set up 7 days retention period. So you say like whatever are older than 7 days, which are not needed, they will be deleted. So if it is just last 3 days, even though it is not needed, it will not be deleted because you need to have that retention period. So in GDPR or whatever it is, they take like, you have to delete within 14 days or so. So they delete now, and after 7 days, it automatically gets vacuumed. So after 7 days, they will not be able to retrieve that data back. So that's permanently deleted. So that's how the compliance works. So using vacuum, so you can do vacuum again. It's delta new. So you can vacuum. You can also cache the table in memory for faster querying. Simple. And then there is something called Z order optimize. What it means is, since we are seeing a lot of files here getting created, right? So you can optimize the files. If you are doing so many transactions, add one row, delete one row, create one row, update one row, right? So every time you keep creating the data files. So it gets too many files, but they are all very small in size. So too many small files or too few big files are not ideal. You cannot have just 3 files of each 20 GB. Not that you cannot have, it's not ideal. Or you have 100,000 files, each 1 MB. So both are not ideal. So ideally, you should have a good size of the files, right? So what it does is when you do optimize, it will merge all the data files to an ideal. So optimum size is 1 GB per file. So it will merge, join, compare all the files into 1 GB files. Probably you can also set the size. Now that is optimized. So when you optimize, again, it just randomly kind of adds the files, but you can do Z order. Z order means, again, it will try to organize the data in the files. So which data should go to which file based on the clustering, based on the keys, coexist the data so that your query is again faster, not just randomly take 3 files and join, but you can also do Z order. So it maintains some kind of co-location or coexist, like department, same keys, data with same departments are all merged into one file, data with another department are merged into another file, something like that. It will figure out how to do the Z order. Okay, so always you do optimize with Z order. So it will merge all the files and it will leave some of the irrelevant files then. So all old files, it will create new files when it merges, and the old files are not relevant, not needed. Then you do vacuum. So you do optimize with Z order and then vacuum. So that is your maintenance or process data life cycle management. You can implement. It's a business policy, how you want to do, how many days you want to vacuum, what is the file size that you want to do. So you can run periodically these commands on the tables, write a script and run these commands on all the tables that it can take care of using this optimize, Z order and vacuum. So I have also added a blog which talks about optimize, vacuum, and Z order. So just go through, read it, you will get more clarity. Okay, these three. Basically, that is the concept. Optimize will merge the files into ideal size of 1 GB, close to 1 GB. Z order will make sure all the relevant data coexist, co-locate similar data. Like say, you can say Z order by address state. So all the address state records are put into one file, one state. So another state are into one file, or data of 2 states in one file. It's not like data of 1 state in 5 files. Okay, so that's how it will try to Z order maximum 99% of the times. Use optimize with Z order. Okay, you can run that. Again. And then this is clean up paths and tables. I don't know if this function is available, so don't worry about this. Okay, so this is about the Databricks Delta features. So this is the heart of Databricks with Spark and Delta and Unity Catalog. These are the 3 main components of the Databricks platform. So this is how Databricks Delta works, and these are all the features. Any questions? I think we are at time. We can wrap up. Any questions before we wrap up, guys? See here.
Arun, I have a question. So when we do any operation,
one second. So here optimize is also recorded. So it will also tell you. So based on address state, you have Z order. You have done Z order by address state. So everything is recorded. So you can go back and track history, what happened at any given point of time. See here, it said it removed 3 files which are not needed. And then all of that data, it has file size, whatever it does, it'll automatically do that. Okay. Yeah, Nabi, go ahead. You had a question.
yeah, so when we are doing operations, right? When we're doing operations on the file system side, it will update the data or only metadata, like what are the transaction we did, or
No, files are updated. So basically, you're not doing any transactions on the file. You are doing on the table. The table has files,
Okay.
underlying files. So those files, it will automatically write. So we have seen delta log, right? So that is what we are talking about here. So if you see, this is delta log, but this is
Yeah,
actual
delta.
data, part 0,
Correct,
0.
yeah.
So this is the file, actual data file. So these files are mentioned in your delta log, which files are, so if you see here, it should talk about your, which file, see here, C00 snappy.parquet path. So this is the file that it says are relevant for this JSON, for this version. Which version? 00 version, right? So this is version, delta log for version 0. So for version 1, it will have different. So it will say which files are relevant for version 1, which files are relevant for version 2.
Oh, okay.
Okay. So that's how it maintains the log, transaction log. So first,
So it's a
whatever query or
transaction log.
operation, yeah.
It's a transaction log will get
It's a
updated,
transaction log basically.
but not actual data file, right?
Not
Parquet
data.
data.
No, data
Yeah.
is data files is this. These are the data
Yeah,
files.
data file is the one. Yeah, okay.
So data
That
files
will,
is the Parquet file. Here, see.
yeah, that will remain
Right?
same. Whatever the data
No,
we
it will
receive
not
first,
remain
right?
same. No, it will not remain same. That's what I'm
So
saying.
it will
Right?
get updated. Okay.
It gets created every time. See here.
So,
So
okay.
C000. These are all the files.
Okay.
Parquet files that you have. 8 files. So if you go to JSON, your delta log, okay, so you will see what are all the for each delta log, what files are relevant, what Parquet files are relevant. So it will only read data from those Parquet files.
Okay.
Every time transaction happens, the old Parquet files will still be there. It will create new Parquet files. And then it will write in the log, hey, for this version, these are the Parquet files relevant to this. So when you go to that, whatever query you do, you'll go to the delta log, transaction log, and then it will see what are the files it has to read. Then it will go and read those Parquet files and then give you the data or do transactions on that data. Okay. Yeah. Okay. So it's not like you will be, again, the things you should understand. It's not like you will be working day in, day out on these kind of things, right? So this is all admin related or, process related, but you should know the concepts of how it works. Basically, how time travel works. It does time travel, but how does it work? This is based on the versioning, based on the Parquet files, based on the delta log, what it writes in delta log, and what files it picks up. So this is how it maintains for each version, what files are relevant. It is able to give you data from that version because it maintains at this version, these are the files. At this version, these are the files relevant. Okay. Any other questions, guys? Pawan is working on creating some assignments or projects, 2 or 3 projects. So you guys can pick up. I talked about, the Kafka and the event hubs. So I don't know where you are with that, but I think I will also add Snowflake to it. So 2 or 3 projects end to end, connecting all of these components. So once he publishes, be ready. You can pick up with whatever project you want to do and then work on that. Okay. Any other questions before we wrap up? Okay. All right, guys. Thank you so much.
Thanks, Arun.
Yeah.
Thanks,
Appreciate your time.
Thanks, Harun. Yeah, bye.
We'll connect. If you have issues, we'll connect. Maybe tomorrow we'll take some time to look at those issues. Okay.